use that phrase more on square roots. And the little subheading today is actually multiplying square roots together. Square roots, when you think of square roots, you should think of just like variables, multiplying them. Okay. If you have the square root of 3 times the square root of 12, okay, square root of 3 times the square root of 12, you can multiply them together. And it's just whatever 3 times 12 is, which is the square root of 36. And as it happens, there is a nice square root of 36 would be 6. Okay? You cannot, children, you cannot, well actually you could, I guess a little bit. I don't want to say that. If I had the square root of 3, I could multiply the square root of 3 times the square root of 4 to get the square root of 12. But I can't add the square root of 3 plus the square root of 4. I shouldn't even call it square root of 4 because this is what is the square root of 4? 2. I guess that's 2 times the square root of 3. Maybe I should say it like this. The square root of 3 plus the square root of 5 is what? What is the square root of 3 plus the square root of 5? Cameron Atkins? Nope. Square root of 3 plus the square root of 5 is, Ryan?
Probably a repeating decimal.
Square root of 3 plus the square root of 5 is, Grace? What did I just say? You cannot add square roots together. So the square root of 3 plus the square root of 5 is the square root of 3 plus the square root of 5. That's all you can do. The square root of 3 times the square root of 5 is square root of 15. Not 15, but the square root of 15. You cannot add. Now you could, let's look at this again. If I have the square root of 3 plus the square root of 3, they are actually like terms in that case, and guess what the answer to that would be? It is not multiplying, I'm adding them together. Let me ask you this question. What is x plus x? What is the square root of 3 plus the square root of 3? 2 square roots of 3. Same thing. You have to think of these like variables. If they're the same square roots, you could put them together like this. You know, the square root of 3, the square root of 5 plus 3 square roots of 5 would be, now if I have 1 square root of 5 and I'm adding 3 more square roots of 5 to it, I have 4 square roots of 5. However, the 3 times the square root of 2 plus 4 times the square root of 3, when I add those together, I get, Cameron Atkins? Yes, that's exactly what I get. That's as much as you can do with that. Now, if I had 3 times the square root of 2 times 4 times the square root of 3, I would get, Alex?
12 square roots of 6.
12 square roots of 6, yes. You can always multiply square roots. They don't have to be like terms or anything. You can just multiply them together. And you will ask, well, when is this going to do me any good? They said in unison. Here is an example problem, and draw this out as best you can. Find, this is where a lot of people run into trouble here. Find the length and the width of this rectangle. It's a little scary. I don't know if you'll be able to do this because some of you just cannot draw straight lines, but let's do this. Let's say we have a Cartesian coordinate system, a graph there, and we've got these points. 2, 2, 1, 2, 2, put a dot there. 0, 4, 1, 2, oh sorry, that is not right. 2, 3, 0, 4, I'll put the coordinates up here so you see them. 2, 2, 0, 4, negative 3, 1, 1, 2, negative 3, 1, And the last one, ladies and gentlemen, kids of all ages, -1, -1. And the book and I are asking you to find the length of this and the length of that. Now, in order for you to get a firm grasp of reality, I am going to load this bad boy up. Okay. Thoughts and suggestions on how in the world I can find the length and the width of those things. Let me tell you, you can't just count things because that won't work, because these are not straight across. This is not 1, 2, 3, and that's not 2 or whatever. How am I going to find those sort of things there? When you run into these problems here, anytime you see, listen to me, focus on me here, children. I need your utmost attention here. Anytime they ask you to find lengths of things that are like on angles on a graph, you are always going to think Pythagorean Theorem. Okay? Because what you are going to do is this. You can always, because you have a whole bunch of perpendicular lines, you've got all the lines going this way and all the lines going this way, you can always form a right triangle with any diagonal line as long as you've got these 2 points. You just go across with one, down with the other, and you've got a right triangle to which this is the hypotenuse of. So if you want to find out what this side is, okay, you know in this right triangle, the distance from here is 1, 2, 3, and the distance up here is 1, 2, 3. Okay, now the worst part about this is it's not going to be pretty. It's probably not going to be triples all the time, those nice ones that work out. But if you're doing the Pythagorean Theorem, remember it is what? A squared plus b squared equals c squared. And if I do that, Houston, anybody know what just happened? Don't worry, I got it. Anybody see what just happened? Here? This it? This it?
Yep.
These are my 2 legs, so it is 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. What is 9 plus 9? 18, right? Equals c squared. And here's that question I asked you bazillions of times. If c squared equals 18, what does c equal? Madison? The square root of 18. And then to which somebody's going to say, can I use the square root of 18? No, you can't, because it can be simplified. There is no perfect square of 18, but 18 breaks down into what? Square root of 9 times the square root of 2, and there is a square root of 9, which is 3. So this side is 3 square roots of 2. That's one side. That would be my length, I guess. And then, children, just when you thought it was safe to get out of the water, then you've got to do the same thing with this side. And again, you just make a triangle, shoot across here, shoot up there.
He said it's a Tennessee.
Oh, I love Tennessee.
Oh, sorry.
All right, children, so then you have to figure out what this triangle is. Well, how wide is this triangle? It is 2 by 2. And then you've got to do the same thing with the Pythagorean Theorem there. For those of you who are lazy and don't have a lot of work to go into a problem, this is going to be a struggle because there's a lot that goes on here. You have to do the Pythagorean Theorem again. A squared plus b squared equals c squared. What is a? 2. What is b? 2. What is 2 squared plus 2 squared? 4 plus 4 is 8. If 8 equals c squared, what does c equal? Square root of 8. Can I use the square root of 8? No, because it can be broken down into what? Say what? Square root of 4 times the square root of 2, and that is 2 square roots of 2. So look, this is 2 square roots of 2. You have now found the length and the width of that rectangle. So you should be very happy with yourself. You should be proud. I would, if you were at home, I would tell your parents because they would probably give you some sort of an award. Now, you're not done with it at that point, Madison, because now listen to what the book's going to do. They're going to ask you for both the area of that rectangle and they're going to ask you for the perimeter of that rectangle. Both of which you've already done all the work. It's going to be very easy to find both of those. Let's do the perimeter first. You have 3 square roots of 2 plus 2 square roots of 2 plus another 3 square roots of 2 plus another 2 square roots of 2. How many square roots of 2 does that give you? 3, 4, 5, 6, 7, 8, 9, 10. The perimeter is 10 square roots of 2. Can we do that again? 3 square roots of 2 plus 2 square roots of 2 plus 3 square roots of 2 plus 2 square roots of 2. That's a grand total of 10 square roots of 2. And the area is nothing more than the length times the width, L times W, and it doesn't matter which one you call what. What do you get when you multiply 2 times the square root of 2 by 3 times the square root of 2? Well, for the numbers, 3 times 2 is 6. Square root of 2 times the square root of 2 is square root of 4. And lo and behold, the square root of 4 is a perfect square, which is 2. And 6 times that 2 would be 12. The area of this is 12 units squared. And again, children, I can't change the amount of work that is. I understand that's a lot of work and there's a lot of complicated, looks like a lot of complicated stuff, but that's the reason why you don't end up with 33 problems. But I should certainly see this on your paper. And I can also tell you there are lots of sheets back there that have half pages of paper that I would use rather than using I would start using the bigger pieces because you can't squeeze all that into one of those little 2 by 2.5 inch boxes that you have there. Doesn't that sound exciting? You know we have to find something here. What lesson is this? 70 something? 78.
How about we do the 12 and 7?
Come on. How about we don't? Which one? 78? I need a problem from 78. But I don't see it. Write these down, because these are the problems to which you shall attend to.